Welcome to my channel, Math Made Easy with Laurel. I'm Laurel, and in this video we're going to take a look at the derivative of the inverse sine function and the inverse cosine function. So what we're going to do is take a look at where the derivative of the inverse sine function comes from. It's an unusual derivative, so I want to show you why it is what it is. So what we're going to do is we're going to start with the inverse sine function, and I just want to point out that when you see a -1 notation with any functions, including the trig functions, it does not mean what -1 exponents typically mean. It does not mean 1 over. It means the inverse sine, and it can be very confusing. I've discussed this in a previous video, so just make sure you understand that this does not mean what -1 normally means. It's just a notation to represent inverse function. So if I wanted to differentiate this, I can't in this form because I don't know what the inverse sine derivative is. However, I can rewrite this same relationship as a sine function rather than an inverse sine function. So this can also be written as the sine of y equals u. Okay? If the inverse sine of u equals y, then the sine of y equals u. Then I can differentiate this. It's now an implicit function, so I can differentiate it implicitly. So I'm going to take the derivative of sine of y, and the derivative of sine of a function is cos of that function, and then times the derivative of y with respect to x, so dy dx, will equal the derivative of u with respect to x is du dx. I want to isolate dy dx, so I'm going to divide by cos of y. I don't want to express my derivative in terms of y. I want to define it in terms of u. So I need to use my Pythagorean theorem. Remember that cos squared x plus sine squared x is equal to 1. Therefore, cos squared x will equal 1 minus sine squared x. And cos of x will equal the square root of 1 minus sine squared x. So what I'm going to do, and you'll see why in a minute, just hang in there with me, I'm going to replace cos of x with this. So dy dx will equal, instead of cos of y, I'm going to write it as square root of 1 minus sine squared y, du dx. Now, look what I've got here. I've got sine squared of y, and we know that sine of y is equal to u. Therefore, I can replace sine of y with u, but remember it's squared, so it'll be 1 minus u squared. So that's the derivative of the inverse sine function of u. 1 over square root of 1 minus u squared times du dx. So this is the formula we're going to use for finding the derivative of an inverse sine function. And we could do the same process with our inverse cos function as we did with our inverse sine. We could rewrite it, differentiate implicitly, and use our Pythagorean theorem and so on. I'm not going to show that. You could try it on your own if you were interested. But the derivative for inverse cos is very similar to inverse sine. It's just going to be a negative. So let's take a look at how we use these two formulas to differentiate inverse sine and inverse cosine functions. So we could have something fairly straightforward like inverse sine of 5x. So if I was finding the derivative of this, remember it's 1 over square root of 1 minus u, in this case, is 5x squared. And then, as always, our chain rule tells us we need to multiply by du dx. So the derivative of 5x is a 5. You'd be expected to clean this up a little bit. So it's going to be 5 over square root of 1 minus 25x squared. And I hope I don't have to say this, but just from experience, I know students try to make things simpler than what they are. And I often see students take the square root of each term. You can't do that. Yeah, that's not allowed. You can't take the root of each term. So just leave it in this form and you're done. Let's take a look at some more. So again, we're going to plug into our formula. It's probably a good idea to have these two formulas in front of you so that you can follow along easier. But we're going to start off by keeping that constant. Then it's an inverse cos function. Remember, that's not a power, it means inverse cos. So the derivative will be -1 over the square root of 1 minus whatever this is. This is your u, so whatever that is, squared. And then you need to multiply by the derivative of this. Remember your chain rule. We multiply by the derivative of 4x minus 1, and that would be a 4. You found the derivative, now it's just a matter of doing the algebraic simplification. So that's going to be -12 over square root of 1 minus. You're going to expand that, so you're going to FOIL it. 4x minus 1 squared is 4x minus 1 times 4x minus 1. Again, you cannot square each term. That doesn't work. So we're going to get 16x squared minus 4x is minus 8x plus 1. And that would reduce or simplify to 1 minus 16x squared plus 8x minus 1. We're just going to distribute that negative to each term. And that would be -12 over the square root of 1 minus 1 is gone. So we're going to have 8x minus 16x squared. So that would be the derivative. Let's keep going. As with any functions, when you're differentiating, you're going to see a combination of all the different rules that we've taken. So in this case, we've got y equals the square root, which I can rethink or rewrite as this to the power of 1/2. Remember, this is not an exponent the way, and doesn't follow the rules of exponents. It's notation for inverse sine. So don't start, treating it like an exponent and using your rules of exponents. It's not going to work. So this function is a power first, and inside the power we have inverse sine. But remember, you always start with your outermost function, differentiate that, and then you work inside. So our derivative will be 1/2 times this function to the 1/2 minus 1. Now we look inside and take the derivative of this. Next, it's an inverse sine function. The derivative of that is 1 over square root of 1 minus whatever this u is. So 3t minus 4 squared. And then we look inside this function here, this polynomial, and multiply by the derivative of 3t minus 4, which is 3. So we have a power function, then an inverse sine, then a polynomial. So your derivative, you just keep multiplying by the derivatives as you go inside. The calculus part is done. Now you're going to just simplify this algebraically. That's going to go in the denominator. The only thing that stays in the numerator is a 3. The 2 goes in the denominator. Now, when I move this down to the denominator, it becomes positive 1/2, but I'm going to switch that to a square root, just so there's no confusion with the exponent thing. This stays in the denominator, but I need to simplify it, so it's going to be 1 minus, when I FOIL this out, it will be 9t squared minus 24t plus 16. Once I just distribute that negative and combine my like terms, I'm going to get -9t squared plus 24t minus 15. So it's just a matter of simplifying and cleaning it up. Let's take a look at one last example. In this example, we have a power, but the power is inside the inverse cos function. So our outermost function is inverse cos. Before we start, let's rewrite this as inverse cos of 3x plus 1 to the 1/2. So I differentiate it starting with the inverse cos rule. So it's -1 over square root of 1 minus my u, which is square root of 3x plus 1 squared. Then I multiply by the derivative of this function, and it's a power, so the derivative will be 1/2 times 3x plus 1 to the 1/2 minus 1, so to the -1/2. Now I go inside the power and I multiply by the derivative of 3x plus 1, which is 3. Now we'll simplify. So the only thing that stays in the numerator is that 3, and it's negative. The 2 goes in the denominator. When I square this, I'm going to have 1 minus just 3x minus 1. So when I square that, it just eliminates the square root, and then I distribute that negative. And I'm just going to write, I'm going to put this in the denominator, and I could write it with a 1/2 exponent, or I can write it as square root. Now I can just simplify this expression inside here. So 1 minus 1 is gone, so it's going to be square root of -3x times square root of 3x minus 3x plus 1. That's our result. So hopefully you're getting the idea of these. As always, the best way to really get comfortable with new formulas is to practice. So find some inverse sine and some inverse cos functions and just practice these questions, especially when they're combined with your product, quotient, and power rules. The next video is going to be on the inverse tan function, which is similar. So when you're ready to tackle that, take a look. In the meantime, take care.